It can only do site to site. So it works out just fine, okay? This entire final works in Packet Tracer, no bullshit, okay? You'll find, you can complain, oh, it keeps crashing, it did not. Nope, not this final. This final works perfectly in Packet Tracer. I will state that to get the VPN tunnels correct, all right, you do have to save your configs. You'll have to, there are one or two ways to make this work properly for you. Save your configs, close the application, save your work, reopen it, or clear the counters. If you clear the counters, this will work properly. And this is part of being a network engineer. You need to know what to do, what to type to get stuff to work. It's that simple. So here, if you follow the bouncing mousey, you got ISP3, okay, connected to ISP2, connected to ISP1, all right? So 1 is connected to 3, 2 is connected to 3. Assume that the cloud extends around all 3 of those ISP routers and that web server at 5.5.5.2. Get it? Public address. Now, if you look at the diagram, you have public pools. These are to be used with NAT. You have a private pool of addresses, 172.31.224.0/19, which indicates 172.31.2240. And gee, it's a 19, so 32. That means 172.31.255.255. That is the address block given to you to assign to all of your internal corporate LAN segments. Now realize you're using .1Q trunks between the router and switch, indicating sub-interfaces on central, at least one for VLAN 5, one for VLAN 6, and a small management VLAN, okay? One over here on our north for VLAN, what is that, 10 and 20. One subnet each and a small management VLAN. In addition to that, you have VLAN 10 and 20 on our south. Understand one key thing. VLAN 10 and 20 on our north have nothing to do with VLAN 10 and 20 on our south. They're totally segregated. They don't even know that there's a VLAN 1020 on our south, VLAN 1020 on our north. The only thing that they know, and they don't know that there's a VLAN 5 and 6 on central. The only thing they know is they learned a subnetwork address via OSPF, learned a subnetwork address via OSPF. They have no concept of the VLANs themselves, none whatsoever, okay? Now, all of the equipment in this hands-on final utilizes username tech1 as the password, as the username tech1, excuse me, and the password of tech123, common. This is what we've been doing since day one. Your enabled secret password is Cisco. That's your privilege exec mode password. Your VTYs will all use SSH and login local. So a lot of this is common to what you've already done. All right. Now, understand one thing. Look at the diagram. From a corporate perspective, Central, ABC Corporation, of which our North and our South are branch or regional offices, okay? That corporate network around the outside perimeter of the ISPs, that means off the global internet infrastructure, would not have the passwords to ISP2, 1, 3. Get it? They wouldn't. Same way as the ISPs would not have the passwords to your central, north, and south routers or switches. They just wouldn't, okay? You pay for access to the internet via a service provider, okay? They don't have your passwords and you don't have their passwords. But this is a hands-on final. You're gonna have to configure multiple devices. It makes sense in this case only, to have the same passwords and usernames on every single device to make life easy. But you need to understand that ordinarily, from an R North perspective, you'd never have ISP 1, 2, or 3's username password. You wouldn't even have R South or Centrals because they're not your network. I hope everybody understands that concept there. You're only responsible for what you do. But since this is a hands-on final, you got to be responsible and understand and know everything. Let's go down to the text on the hands-on final. Now you see here, actually, let's stay with the diagram for a second. Over here on Central, you have a .1Q chunk. That means Central's router is going to have at least 4 sub-interfaces. 1 for VLAN 5, 1 for VLAN 6, 1 for a management VLAN between the router and the switch, and 1 to act as a native VLAN between the switch and router. Same thing over here on our South. There's going to be 1, 2, management, 3, native, 4. Over here on our North, there's going to be 1, 2, 1 for VLAN 20, 1 for VLAN 10, VLAN 100 for your management, and VLAN 101 for your native. Realistically, I don't care what number you make the management and native, as long as it works. If it works correctly and you configured it correctly, trust me. Where's my finger? There it is. I'll understand what you were doing. But if it ain't configured correctly, I'm gonna think you might be kind of dumb. Anyway, ISP1 has 2 links on it. 198.5.5.252. That means ISP1 would be 253, or North would be 254. Okay? Between ISP2 and R South, you have 210, 10.4, indicating ISP2 should be 5, and R South should be 6. Between Central and ISP3, you have 222, 123, 6.252. Low number on ISP3, indicating 253. High number on Central serial interface, indicating 254. You understand how I operate here. This is the way I look at things logically. Out to the LANs is the high numbers. In to the ISP are the low numbers. You could do it whatever way you want. I don't care. But when it don't work, this is a hands-on final, and I'm going to cry about it. And I'll keep sending it back until you understand and get it right. If you look at ISP 1, 2, and 3, okay, what you have here is a link between ISP 1 and ISP 3. So if you have a link address of 140.80.255.4, okay, I would make .5 ISP3, .6 ISP1. If you have a link between ISP2 and ISP1, 3, your link address is 200.210.0. I would make ISP3, 1, ISP2, .2. All right? Same way as you see the 210.10.4, .5, .6. Lower numbers up to the core, higher numbers out to the segments. Now, these are your, right here, your public pools. That's what you're using for NAT. BGP will never advertise your NAT addresses unless they're instantiated. How you like that word? That means there must be an instance of your public addresses for your public pool of addresses to be communicated to other devices. So that means on R North, R South, and Central, you're going to have a static route to your public addresses. That route destination will be null zero. That puts your public addresses in your routing table and therefore allows BGP to communicate those addresses to other BGP speakers, routers. Okay? Going down, let's go to the text now. It says, given the diagram above, configure as specified and provide documentation. That means I want a config for each device, ISP 1, 2, and 3, or North, South, and Central, and switch Central, South, and North. I do not want the end station configs. They don't matter to me. The final requires generic routing encapsulation over IPsec to route the interior gateway protocol, allowing connectivity between customer sites through the internet. In this case, the Corp Central Hub, okay, Corp Edge, whatever, the hub, R North and R South. Those are the customers of the ISPs, okay? Central is your corporate hub router configured to site-to-site IPsec VPN tunnels, one from R North to Central and one from R South to Central, but not one from R North to R South. Remember, in this case, Central is the hub. That means a VPN from R North to R South, to branch regional offices, whatever, must go through the central site. Okay, ISP 1, 2, and 3 should announce a default route to their attached customer router, but not to each other. Announce the public address pools assigned to the provider via BGP. Now that's where I was talking about a static route to your public addresses pointing to null zero so that they appear in the routing table. Then you can just issue a network command in BGP with the mask and they'll be routed. Okay. As far as ISP 1, 2, and 3, announcing a default route to their attached customer router, that one facet does not work in Packet Tracer, but there's a workaround. Okay. When we get to it, I'll explain it. Right now, it doesn't matter. Okay. Central, R North, and R South routers should be configured to distribute their private addresses via DHCP to their respective LANs. Now, if you look for, go ahead, what's that? What are you saying? Somebody got a question?
That was an accident. Sorry.
All right. So if you look at it, our North, South, and Central should issue DHCP to the respective VLAN subnets. However, remember that each R North, South, and Central, each router has one VLAN with one address that should be statically assigned. Why? Because you have static NAT. Also, which means that if I'm on R North and I ping the public address of Central's host that's statically natted, I should get a response. Okay? Same holds true for R South to Central, Central to R South or R North. On each LAN segment, there's one host that has a static address and a static NAT translation. Okay? The rest of it is all PAT, port address translation. All right. So you got to configure NAT and PAT as needed on all corporate routers. Designate one address on our north VLAN 10, our south VLAN 10, and central VLAN 5 segment for static NAT. All others are used in PAT pools. Our north switch 1, our central switch 1, our south switch 1 have to be configured to support the VLANs for the LAN segments identified. Create native and management VLANs as necessary. I only identified on the final the user VLANs. You're supposed to know you need a native and management VLAN to manage the equipment and to enable layer 2 protocols device to device. Routers and switches at each customer site should be able to reach each other via SSH. No host should be able to SSH to routers or switches. Create ACLs that satisfy the following: the lower half of VLAN 10 on our south should not be allowed internet web server access. That means VLAN 10 on our south should not be able to access that 5.5.5.2 host. The first 16 addresses on VLAN 20, our north, should be denied access to the internet web server. The rest of the addresses should be allowed. ICMP should be allowed to and from all LAN segments to every other LAN segment, okay, and address. Okay, so since that is pretty much it, let's get over to Packet Tracer. Now I'm going to be bouncing back and forth between this diagram, okay, and Packet Tracer. So if you look at it, this is kind of obvious, I hope, to you guys. This router right here needs at least 1, 2, 3 Ethernet interfaces. Pretty much the only device in that list is a 2911 that allows for 3 Ethernet interfaces. Okay? This one only needs 1. This one only needs 1. This one only needs 1. So I don't care if you use 43 21s for that. However, this one router has to be a 2911 because it's the only one in the equipment list that supports 3 physical Ethernet interfaces. Okay, so I'm going to start dragging out equipment to build this up in Packet Tracer. Can everybody see Packet Tracer now? Somebody say yeah.
Yeah.
Okay. All right. So I'm going to look a little stupid here because I don't have any contacts lenses in. All I got is my eyeballs and my glasses, so I can't see nothing here. There's a 2911. And since I like 2911s, I'm just going to create a whole bunch of 2911s. That's a 2901. I ain't working with that. Not that I have anything against them. It's just not my thing. Okay, so here's another 2911. So there's our ISP3, right? Let's keep going. There's north, south, central. We need a couple of switches here. We could do with 2960, 2960, 2960. Okay. From there, we need a couple of hosts and devices. We need at least 1, 2, 3 PCs here. Okay. 2 for VLAN 10 because that has a static translation, right? And then you have another host that needs a dynamic translation as well as DHCP. However, this one has to be static. That means that has to be excluded from your pool. Yeah, I caught that 2901. They're all 29. Oh, look at that one. He snuck in there. Let's get rid of him. Dead. Okay. And then let's take him. Let's close that. Control C, Control V. Here we go. Happy now? Go ahead, say it. Say it. You're happy, right? It ain't a 2901 no more. So each of these segments on our north, south, and central is essentially going to have 1, 2, 3 PCs. Okay. And I'm going to clean this up later, as we go along and we start connecting stuff. I just want to get the necessary equipment out there. And then there's one more PC that's emulating some Ethernet, web server out on the internet. Okay. Does everybody see this? Yeah? Yay? Hooray.
Yeah.
Where'd you put the server? You put the server in?
Well, you know what? Here, let me.
It's a PC. Okay.
Yeah, I used the PC. Let me get rid of that. Let's do this right. Since you went and complained about it, here's your damn server, okay? Anyway, so let me zoom this somewhere out. There you go. All right, so we have over here, we have a host in VLAN 5, another host in VLAN 5. I think that's the one that has the static NAT translation. I could be wrong. I'll look at it again when I get there. I just want to pretty this up so the connectivity is easy. You know what I mean? I can get everything wired and connected. So there's that switch. And then you've got those 2 hosts and that host. Over here, you've got those 2 and that one. And over here, we've got those 2 and that one. Now let's drag some cables out here. First things first, we're going to need some serial cables. All right. So this router right here.
Hey, Chris. I'm trying to every time I click on any device on Packet Tracer, it's just giving me the CLI. It's not giving me the physical.
Because when you click on them, it technically opens up the CLI. Just close that. What do you mean the physical?
For me to
open up the device?
Yeah.
All right. So here, let me just set this ISP1.
You might have some. Oh,
that's set. If you if you click once, you get this. You want the CLI? Or you want to add links? If you want to add links, you have to click on the links.
No, I know that, but
I've had that same problem where it's just the CLI and the tabs.
Yeah.
And you have to go into the options and you have to re-enable all of the other options so that the tabs appear. They're like in options or something.
Is it in preferences?
I mean, you go to the actual packet tracer, like, file, edit, options, view.
Okay.
You go into one of those, and you have to find these little boxes that you check off to make sure that certain tabs are enabled.
Field show. Yeah. In other
Gotcha.
words, stop messing with your packet tracer and let it run at default.
That's what I've never even changed this, but
Yeah, it happened to me just weirdly one day, but I was able to figure it out.
cool.
Mm.
Do you got it? Do you get what he's saying?
I think so.
All right, whoever needed the final, I sent it. Somebody asked for the final, I sent it.
Thanks.
All right, so what I'm gonna do now is I'm gonna start adding equipment to these routers because we need some serial interfaces. Okay? Let me just position this equipment. This way it makes our lives easier as we're going through this. You should be doing the same. Don't be bullshitting. I ain't gonna cover this but once. I'm letting you know.
Alejandro, did you get it? I think I found the specific place you need to go to.
Yeah, I got it. Thank you.
All right.
All right, now the reason I named these PC1, VLAN 10 static, is because I believe if I go over here to the diagram, it's gonna say, okay, where is it? Designate one address on our north VLAN 10, our south VLAN 10, our central VLAN 5 for static NAT. All others used in PAT pools. So this is a static NAT. Okay? This is dynamic NAT as well as dynamic DHCP. Whereas this is static addressing. This is dynamic addressing via DHCP. So the address assigned to this host statically has to be excluded from the DHCP pool for VLAN 10 in R North. This address here is dynamic, DHCP, and NAT, okay? So let me rename this router R-North. This is ISP dash, let me go over to the picture, 1. Okay, so if this is ISP 1, this is ISP. See, duplicate names not allowed. So let's change this one to ISP 3. And this one is ISP 1. That makes this one ISP 2. making this our south. And this central. Okay, that would make this, what did we use for a name here? RNSW1, RCSW1. You get the idea, right? So this is RN-SW1. This is RS-SW1. This one here, central or cent SW-1. Okay, this is simply the web server. Web serve 5.5.5.2/29. Now you see, as you're documenting this, it's going to make your life easy because you know whatever cable you connect here has to have that address. Okay. All right. So up here, this is going to be central PC1. And this one is going to be VLAN 5. And if we go over to our documentation and we read central VLAN 5, we'll have a static address, okay? So this is central VLAN 5, static. Whereas this one is PC2 sent PC2 VLAN 5 dynamic. And then this is simply PC3 VLAN 6. And these two over here are going to be PC1 VLAN 10. Now let's double check. Let's just make sure. VLAN 10 again. Okay. So that's VLAN 10. Static. And this is PC2 VLAN 10 dynamic. Oh boy, I see what's going on. Okay, PC1 VLAN 10. What is that? PC? Come on, man, stop messing with me. Watch it cause errors. Okay, that one took. Oh, that says PC10. Come on, open it. God damn it. PC North. Okay.
Chris,
Yeah.
I was just wondering why you have 3 PCs when it's on the diagram it's 2. It's probably just like written like that way, right? But it's just not physically shown.
Did you read it? Because I've been explaining it as I've been putting it together. Did you read it?
Oh, okay. Okay.
You get it? You got one that's static on VLAN 10, one that's static on our north, and one that's static in VLAN 10 on our south. You have one that's static in VLAN 5 on central. That means the other nodes are going to be dynamic. And since we're issuing DHCP and we're doing both static and dynamic NAT, you're going to need to test this. You're going to need 2 PCs where the static addresses are and only one where the dynamic addresses are. Does that make sense?
Oh yeah, that makes sense. I was just wondering why it looked different.
What you have in documentation and what you need to produce to emulate something are 2 different things.
All right.
You have static addressing and the rest are dynamic would be assumed, then you need to provide 2 hosts, one static, one dynamic, so you can test both aspects of connectivity. Okay?
Okay. No, I understand that. I think that makes sense.
That's why I said I'm going to explain it as I go along so everybody gets what I'm doing.
All right. All right.
All right. So we got PC1 here, north, VLAN 10 static, PC2, and I'm going to put an N here because it seems to be a problem with the duplicate names, north, VLAN 10, dynamic, and then we have PC1, south, VLAN 10 static. Let me just clean that up and put a space in that. And then we have PC2, south, VLAN 10, dynamic. And then we have PC3, south, VLAN 20, dynamic. Okay, so we have all of our devices are now named. Okay, and this should be PC1, this VLAN 5, that's separate. So what we need to do now is start connecting cables. Okay, the problem is we can't exactly connect cables yet because this router and this router need a serial cable. This router needs a serial cable. This one to this one needs a serial cable. There are no serial interfaces in the devices. So open the device, the physical, power it off. If I can find the damn power button. Modules, wick cover. Let's see if it's on or off. I can't tell. Can't add a module while the power's on. So press the button, it's off. Cover, cover, cover. And then a wick 2T, HWIC 2T, HWIC 2T. Power it up. Close it out. ISP1. Power it off. Put in a wick 2T and 3 HWIC covers or wick covers. Power it back up. Close it out. On this one, go over to the physical, power it down, wick 2T in module 0, 3 wick covers, 1, 2, 3, power it back up. Can't see if it's up or down here. You know how I can see? Okay, it's up. Come over here. CLI, nope, physical. Power it down. Wick 2T. 3 wick covers. Power it back on. Close it out. Come over here, power it down. Wick 2T. 3 wick covers. Power it up. Did we get this side? Nope. Power it down. Wick 2T. 3 wick covers. Power it back up. Close that out. Did we get this one? Yes, we got this one, I believe. Yes. Okay, so all our devices have the necessary wick cards, covers, etc. They're all good to go. We can cable everything up. So click on the serial link. Now, in this particular instance, I would click the one with the clock. Why? Because the ISP always provides the clock to the customer. I would use serial 000 on ISP1 to connect to serial 001 on our north. I would also click the clock link again, 000 to 001. One more time, 000 to 001. Then I need an Ethernet crossover to go from G000 to G000. I need another crossover to go from, come on, man, G01 to G0, come on, God damn it, 1. Then I need one more, in this case, to go from G02 out to the server, fast Ethernet 0. I also need cables, straight throughs in this case, to go from the switch gig 02 to this router's gig 02. Straight through gig 02 to gig 02. Straight through gig 02 to gig 02. Okay? Then I need a straight through from F0 on the computer to F01 on the switch. Straight through to go from F0 to F02. And a straight through to go from F0 to F03. Then I need a straight through to go from F0 to F01. Straight through to go from F0 to F02. And a straight through to go from F0 to F03. I need 3 more straight throughs, one to go from F0 to F01, another one to go from F0 to F02, another one to go from F0 to F03, okay? Now, all of our cables are connected, everything's straight. We need to add in some additional stuff, okay? You guys want to take a couple of minutes and catch up, get your stuff positioned in packet tracer? Tell me now.
Yes, yes.
Yes.
Let me clean
Okay,
mine.
get your cabling straight, okay? Cable your devices, connect them together in a simple, logical manner. PC1 to F01, PC2 to F02, PC3 to F03 on each switch. Make your life easy, man. If you do this logically, configuration falls right behind. Now, once you guys are done, I'll give you 15 minutes to get yourself straight with setting up the diagram itself. And then I'm going to begin to label links with addresses so that we can readily configure this 1, 2, 3 skidoo. Okay? So take 15 minutes, get yourself set up something similar to this. Name your stuff, try to do it appropriately, logically. Do it logically. Whatever logic works for you. I like my logic better though. So take 15 minutes, get yourself straight. What do we got? It's 10:38. I'll give you the 10:45, 10:50. What is that? That's 10:12. Okay, 10:55, 11 o'clock.
11 o'clock. Nice.
Get this together, all right? I'm going to mute my video. I'm here. If you got a problem, give me a holler. You got till 11 o'clock to get it right.
Quick question. Is in Central?
The answer to your question is no. You should have been paying attention, damn it. What do you want? What do you need?
Is PC3 VLAN 6 or 5?
Central, yes. PC3 is VLAN 6. That's what's typed there.
Okay.
I don't know if you can zoom your screen or not. I don't have many options here. Now, do note, after all that hard work that I'm doing, you know what I'm going to do? I'm going to save that damn thing just in case, because you never know when Packet Tracer is going to let you down. So, sem 3-enza-final, just in case. How's that sound? All right, you guys good? I'll give you till like 11 o'clock to get it together.
Chris, can you show the logical interfaces?
What do you mean? What do you mean logical interfaces?
Like so it can display where is what connected. I mean, I know most of them is like S.
Is there an option to show that? Because
Yeah, right there, option preferences.
Yeah, it's
and
under.
then
It's under
always
interface.
show right there. Always show port labels.
what the hell is?
Higher to the left, to your
In
left.
the left column.
Right there. Oh, there you go.
I never use that stuff.
Because you're a
It's
pro.
labeled on the physical
Go.
devices. I mean,
Let me
Sure,
see if I
pro.
can stretch it. See that? Then you're gonna make my shit ugly. My shit was looking good until you put these labels here.
Sorry.
That's messed up. I like my stuff to be pretty. I just have a tendency to remember what's what. There you go. Let's see.
We're not as smart as you.
Nah, I ain't smart. Trust me, I'm as dumb as a box of fucking rocks, man. If you ain't figured that out yet, I don't know what to tell you. I'm just good at what I do.
Nothing says you can't turn it off when the screen shares off.
What? How's that? Can you see everything now?
Yeah, if you can just zoom in a little bit, that'd be great. Thank you.
It only goes one level.
But it was fine earlier. What kind of?
I'm working on it, man. I'm trying to get that one back. That's it. That's all you get. If I do it one more time, it goes small.
All right, no worries. That is a lot better.
All right?
All right, thanks.
All right. We ready to roll on? We got some more labels to add in here.
Ready.
All right. So if we go back to the diagram, so the screen's going to change. All right, looking at these devices. You see here that our south has an AS number of 64,002. Okay. It also has a link value of 210, 10, 4, 210, 210, 10.4/30. So let's take this AS value, copy this, paste it into Packet Tracer as a note. Okay, so that's our south's AS value. Okay. All right. We need the link value. Control C, let's paste that in as, oh, that don't work, does it? Let's see here. Not exactly pretty. I hate these things because once you paste them, it's kind of like impossible to move them. So Control A, Control C. Let's delete that one and move it up a little or something.
I think you can actually move them.
They don't move for me. There you go. Okay, so there's the link value. There's the AS value for our south. Then we got to go back here and we need the AS value for ISP2. Control C, pop back over. We can paste that right in, hell, on the label. And
No,
what?
Sorry. No, if you create a note, you can move a note. You just have to hold down on it and go back to like there's like the delete, and then there's the hourglass.
Okay.
Yeah.
I got it. See, that's what you get for not using Packet Tracer much. I don't use it much at all. All right, so there's our, let's see if I can get this to break open a little. ISP2AS. There you go. Nope, it goes back to what it was. That's okay. Anyway, let's go back and get the rest of our AS values to paste in. So this is ISP3. Come back in here. Let's click there. Control A, Control V. Let's hope it becomes something. Nope. So I'm going to Control Z that, get rid of that. Let's leave that with that and just drop a label next to it. Go back and grab another one. All right, this is central. Drop a note there. That's the AS4 central. Come back in here, ISP1, Control C. Control V. We need the AS for north.
Oh, jeez. All right, so that's that. We can get rid of this here since it's right there. Central's AS value. Okay, so we got the AS for south. We got the AS for ISP2. ISP3, central. Is everybody clear on that? All we did just now was copy over the AS values to make our lives easier. We also copied in this link value. We're going to have to copy in the link here, link, link. Okay, so we have that addressing. So right here, Control C. And then we drop back over, paste that label. Grab this one. Drop that label. And then we need this one here. Okay, let's make sure we got everything. We didn't get this one. Okay, now you see this address block right here. It's 172.31.224.0/19. That has to be subnetted for this management VLAN, actually it's realistically it's these two. That's a VLAN, VLAN 10, VLAN 20, VLAN 6, VLAN 5, VLAN 10, VLAN 20, as well as the management. Okay, so you have to subnet that out. I'm gonna let you guys do that. You come back and tell me, somebody paste me the subnetting chart for that based on reading the final. Now look at the final. You have 400 nodes on VLAN 10 for over here. 300 nodes VLAN 20 over here. You got 300 nodes VLAN 10, 300 nodes VLAN 20. Up here, you have 95 nodes, 195 nodes. So you need 1, 2, 3, 4, 5, 6, 7, 8, 9 subnets. That's your 2, 4, 6 user VLANs subnet. 1, 2, 3 management VLANs subnets. And then the native VLAN, don't worry about, that doesn't require addressing, okay? So if it's 11:18, 11:19 right now, I'll give you about a half hour to subnet that out. And then somebody...
Vape break.
What?
Vape break.
Vape break? Okay, so here it's 11:20. You got till 11:35 for your vape break. And then 25 minutes to subnet it out before lunch.
All right.
All right, sound good? Remember, if you're doing this, file, save. Oh, well, that's the wrong one. You want to do it in Packet Tracer so you don't lose your place. File, save. Okay? So there's what you got. I'll paste the requirements here. Our north is, let's see here. RN V10 300 V20 300. Okay, that's on north. Then you've got damn it. Our south, V10, 400, right? V20, 300. Okay, and then sent, V5, 95, V6, 195. So there are your needs right there. You need to subnet according to 300 nodes on R North V10, 300 nodes V20 on R North. R South, 400 nodes on V10, 300 nodes on V20, and then Central, 95 nodes on V5, 195 on V6. Remember, you also have on each one of those a management VLAN. Give them like a 26 if you got enough address space. Okay? So work that for a little while, get those numbers together. You tell me, we'll proceed from there.
Chris, you were muted for a second. What was the last part that you said? Chris, your mic is muted.
Yeah, I said work those numbers. In other words, subnet that 172.31.224.0/19 to meet the need for R North VLAN 10, 20, and the management VLAN, R South 10, 20, and the management VLAN, and Central VLAN 5 and 6, and the management VLAN. Okay?
Okay, thank you.
All right. remember those public pools are for NAT only. Look at them, they're /29s. There's not many addresses there. You have to subnet for VLAN 5, 6, 10, 20 on our north and our south from the 172.31.224.0/19. Okay? How's everybody doing with that subnetting? You got it done?
Ah, so you had them subnetting this whole time.
Yeah, they're supposed to be subnetting this.
Yeah.
Subnetting's all done, everybody? See, now I would give this some thought. I'm just going to put some food for thought before lunch up there. Okay? And go from there. So if we have over here, we have 300 and 300, right? So what if we set on our north? Let's use, let's say 172.31.224.0/23. That would make the next network. Now this would be VLAN 10. Okay. Let's try to get this where it's like kind of pretty. All right, so that's VLAN 10. Then you got VLAN 20. And let's say that's 172.31.226.0/23. Then you have your management VLAN. Okay, that'll be 101. So let's call that VLAN 101. And supposing we had 172.31.228.0/27. That's all we need on our north. Yes, they are always on their own subnet. Okay. Let's move this up out of the way a little bit and let's look at our south.
Chris?
Yeah.
Just wonder, I thought you told us to, when we subnetting, always start with the host with the most nodes. So I thought we were supposed to start subnetting using the router south with the 400.
Well, 300 and 400 works out to be the same mask, doesn't it?
Yes, it does.
That doesn't matter.
Oh, okay. So will it matter if we decided to go the other route, starting from router south?
Yeah, well, actually what I was going to do is leave two, let's say 2, 4, at least 5 networks per router. So realistically, it would be 6. And as far as the /27, it's because you need enough addresses to address however many switches or stacks of switches necessary to support the node count. So if you have 948 port switches, like VLAN 10, they can all be managed with one address. Then you'd need another address for VLAN 20. Does that make sense? So you need addresses for the switches.
Yes.
Okay?
Okay.
Now, if I went over, now watch this. If I go over here to our south, I'm going to do our south. You could have done this differently. You could have went with our south, our central first. Doesn't matter to me, as long as your addressing is correct. But remember, I did say something about you might want to pretty it up, right? So if you got VLAN 10 over here, that would then get 172.31. Now look, we left off at 228, right? So if I went to 31.2 30.0/23. And then VLAN 20. 172.31.232.0/23. And then the management VLAN 101, if I went to 172.31.234.0/27, I would be done over there for our south. And then if I went up to central, and on central, I used 172 dot. Now we ended on 32, right? 34, because 232 with a 23 takes you to 234.0. The next logical increment on a 2-bit in the third octet would be 172.236, 172.31.236.0. Okay, and then that would be for the 95 nodes, let's just call it a /24. Okay, and then we go out to, now that is VLAN 5. Then we go to VLAN 6. Okay, and that's going to be another /24. 172.31.237.0/24. And then the management VLAN 101 is going to be 172.31.238.0/27. So there we have all of our subnets subnetted out. We still have a lot of addressing in reserve, right? Because 224 goes up to what? Based on a 19-bit mask. All the way up to 255, doesn't it? 31? Yes? Yes, Chris?
Correct.
Yes, Chris.
That makes sense to everybody.
Yes, Chris.
We have nice clean blocks for each LAN. And with that, guess what time it is? It's lunchtime. We come we'll start configuring some of this up. I'm only going to configure a little bit of stuff. You guys are going to have to figure out the rest based on what I do. Okay? Okay, Chris. Thank you.
Okay, Chris.
Okay.
You benevolent leader, you. So,
Thank you.
see you at 1:10. Okay? Lunchtime till 1:10. All right? Lunchtime till 1:10. You can copy out these address blocks if you want. And we'll resume at 1:10. Okay, people?
Sounds good.
All right. That's it. Lunchtime. See ya.